Okay. Hello, everyone. Um, for today, I will finish hopefully all the polar and parametric equations. But before we continue, I think I forgot to mention and to make sure that uh, how to make sure that what we draw are correct, or how we can draw the polar curves. Okay. Okay, for example, I want to focus on this circle here. Okay, and again, in this particular graphs, this is not x, okay, not y. Okay, but, sometimes if you are begin to know what is polar coordinates, you will be mixed between x, y, and r theta. Okay, what is polar coordinate? Is basically you have r and you have functions of theta. So this is basically what coordinates in general terms equations. Okay, so the function is based on theta. So if I have, for example, okay, if I have r equal 1, okay, if I have r equal 1, it should be in the polar because it's not mentioning any angles, any degree, right? So it should be at all angles, the radius should be 1, which is why we get the circle. Okay. So this is, for example, okay, this is example, r equal 1. So this is 1. This is also 1. This is 1. This is 1. Okay. Okay. Do you get it? Okay. Again, okay. This is not y, not x. Okay. This is just to help us to draw. But how do we start? We start from the beginning. But because we have r equal 1, our angle anywhere in these curves will be radius 1. Okay, r equal 1. What about if I have just theta is pi over 4? What's the graph to look like? What's the graph look like if you just have just theta is pi over 4? Here, if r equal 1, then it's just circle. If r equal 2, then another circle but bigger. R equal 3, larger. Okay, the circle becomes larger. But here, pi over 4. Who? No, not circle. No. Yeah, what is that? No. Not necessarily like that. Yes, line. A line. Why? Let's think. Let's say this is 0, 90, 180, 270. Okay. 0, 90, 180, 270. By the way, do you prefer using this or using pi, or both are fine? Okay, let me just use in this. Okay, so 0, 90. So 45 is around here, right? So if you just have theta is equal to pi over 4, then yeah, this is the line, okay? This is theta pi over 4, okay? Do you accept that? Okay. In x and y, what is the line? If it's cutting perfectly in the middle. Yes, this is perfectly similar to y equal x. Y over x is tangent, right? Y over x equal 1. Tangent equal the 45, right? Tangent 45. Okay? Got the logics? Or you got lost? Okay, here. So y over x is equal 1, right? I have theta here. This is y, this is x. Okay? Well, I have tangent theta is y over x. If tangent theta is 1, then theta is 45. Okay? And that's why when we have a polar curves, when theta is pi over 4, it's exactly the same as y over x in xy axis. Okay? This is just to make a relations between the xy axis and the polar curves. Okay? Okay, again, in the polar curves, this is not x, this is not y, this is the angle. Okay, all this. Usually you will have to help you to draw. Actually, you can draw line like I drew yesterday, and then maybe connecting like you have circle, 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 like maybe like this. Okay, the first circle, second circle, and third circle. Okay, so you can see and draw easily if you draw the circle. Okay, so this means 1 unit, 2 unit, 3 units. Okay. Okay. Now let me go back to what is R. Okay. So if this is R and this is theta, if this is R, this is theta, of course, if you are moving your points all through this circle, can you find the radius which are negative or no? Can you find the radius which is negative or no? If you are moving, again, it's not x, it's not y. There is not any positive or negative, right? But there might be equations that tells you that the radius is negative. But how you draw that? How you draw that? It will be reflected. It will be reflected. So actually, the radius will be reflected here. Let's say, let me assume this is the negative r. Okay. If it goes by any negative in radius, which means you need to move to the back side. Okay. Because okay, in this polar, our mind, okay, our perspective should be circling around. Okay. Different with the xy, which we can make like a rectangle, right? Like point xy, 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 right? In r theta, so this is the, we can say also this is polar coordinate in terms of r theta, which means if r, let me draw, let me write 1 pi over 4, okay? Which means this point is when theta is pi over 4, radius is 1. So maybe if this is 1, 2, 3, this is the point. Okay. And maybe if you want 1 pi over 2, this is the point. Okay. In pi over 2. Okay. And how you move is you move like a circle. Okay. Keep that in mind. Okay. Do not mix with the xy. So if happen in your graph, the radius is negative, when you're moving, then you flip mirror the radius to the back side, the back of the center. Okay? That is what happened when you draw the yesterday graph. Let me show you how. Let me check the equations for you. Okay, let me start with the R is cos theta. Okay, let me draw the default graph that you all know about cosine. Let's draw this, okay, and make this 1, -1, and have this, let's just start from pi over 2, pi, 2 pi. And then start from 0 is here, and then at pi is negative. Okay. Because you know what? In cos or sine, sometimes you will get the negative value. And where you will put the negative in the graph, right? Right? That is when you need to flip the radius and going back to another side. Okay. Let me just remind you this default graph. It's not perfectly fine, but I think you know the cosine very well, right? So start from 1 and go to -1 and bumps up to 1. Okay, and then it's going up and down all over. Now, how we draw the r cosine theta in the polar coordinates. Yesterday, I already made a conclusion. It should be a circle, but in the right side of the axis. Okay. This is 0. Let's say 90, 180, 270. Okay. We can compare these two. Okay. 0 is 1. Okay. Maybe here. And then it's reduce, decreasing. And at pi over 2, at 90, it's 0. So it's from here. Okay. Okay. So I will draw. It's 1. Okay. Now, from 90, let's say to pi, to 180, it goes to -1, right? How to draw it? If you have uh, just a positive, if this is positive, it should be from here to here, right? Right? But you need to reflect that. Okay? The radius become the negative. The -1 is reflected to this side, right? And when you have pi goes to 270, so pi go 270. It should be started from 1, from -1 to 0. So it should be like this, but it's reflected to here. So this reflected to here, and this reflected to this. So that's why we have a full circle. And another 270 to 0, 2 pi, we get from 0 to 1. From 0 back to 1, right? So I will draw the red color, okay? Which is what I want to say is this red color here, because in the polar curves, there is no negative form. The negative form is, for example, if this is the radius, the negative r is here, okay? You got it? The logic, okay? So that's why this is not included. Okay, good. Okay, that's actually how to draw. Okay, if it is still not making sense, let's try the flower. Okay, the flower one, the petals. Okay, or the rose. Okay, some books using petals, some books using rose. Doesn't matter. So let's try r is cosine 2 theta. Let me draw the cosine graphs. Okay, because now it's 2 theta. Let me divide by pi over 4. Okay, pi over 4. Okay, yeah, more or less, this is the cosine 2 theta. Okay, so you have pi over 4 instead of pi over 2. Okay, uh, different periods. Okay, different periods. Now let's move to the polar. Okay, and because we have pi over 4, let me have pi over 4 as a guideline in our graphs. Okay, yeah, hopefully it's 45. Yeah, okay, now this is 0, this is 90, 180, 270. So we start from 0 to pi over 4. Let's say this is pi over 4. Okay, this is a pi over 4. So start from here, it's 1, and then goes down to 0. Okay, goes down to 0. So it's going like this. Okay. Let me use green. If this is 1, then it should be, yeah, more or less like, yeah, hopefully you can see it's going down here. Okay, now from pi over 4 to pi over 2. So pi over 4 here, pi over 2 here. So it should be from here to here, right? If all positive, it should be this way. But we see here, pi over 4, pi over 2 is negative, right? So it should be from 0 to negative 1. Let's just think positive first. It should be here, but because it's negative, we need to mirror this uh, curve to this line, mirror, and we get here. Okay? Okay, next one. From pi over 2 to 3 over 4 pi. From -1 to 0. Okay. So it should be from here until here. Should be from here. If all positive, it should be here, right? But because it's not, we have to transform and mirror the curve to here. Okay. So the next one is this. Okay. Now from 3 over 4 pi to pi. Okay. Oh, it's positive, right? It's positive now. So from 0 to 1. So from 0 to 1. Okay. Okay. And then the next one is from 180 from pi to 5 over 4 pi. Nothing wrong with this graph. It's 1, 0. So 1 and back to 0. It's going back here. It's a little bit thick, but yeah, whatever. It's like a flower. Okay. And then from 5 over 4 to 3 over 2. So 5 over 4 is here. 3 over 2 is here. It should be this, right? But because it's negative, it should be going behind. Mirror with this line, mirror, and then we get this. And then from 270 to 7 over 4, we get going back to 0. It should be this, but because it's negative, it should be the other way around. Okay. And the last part is nothing wrong with here. 7, 4, 2 pi. It's 0 to 1, 0 to 1. Okay. Okay. We got the 4 petals of roses. Usually the textbooks call the structure is rose or petals or leaf. Same thing. If you have cosine 2 theta, or so if even number, if you have 2 theta, it will become 4. If it is 4, it becomes 8. If it is 8, it becomes 16. If it is 3, it's 3. It's 5, 5 for odd. For even, it's twice. But I will tell you later that property. Okay. But at least for now, in this graphs, you get the idea why the graphs like this. Okay. So whenever you are drawing and you see the radius is negative, which means you need to go behind. Okay. So if this is positive, the negative one is behind that positive, which is it's uh, it's weird at the first time, but in the polar, it makes sense. Okay. Because actually there is not exact negative in the point. Okay. But when you draw, when you counter the negative, it means the opposite sides of the radius. Okay, the mirror of the radius. Okay, any questions? Okay, let me give you some time to breathe and take these notes. Okay. I will review and give some example from yesterday, and after that we can go for this rows and other form. You will be learning the polar all over again in calculus chapter 10. It's parametric equations and polar coordinates in calculus. And then you'll be using this again in, yeah, I think chapter 10, because chapter 10 having both derivative and integrals. And you need to derive and integrate in the polar curve. Okay, so the first thing you need to keep in mind when you are shifting the axis from the xy or rectangle to polar is you need to know how it works. Okay, you know to this polar, the point coordinate is r and theta. So it's moved on circular motions, different from the xy axis. Okay. Okay, let me give you example from what we learned yesterday, and I'm reviewing a little bit. Okay. So so yesterday we have uh, a sine theta and a cos theta, right? Now the difference, okay, uh, sine is having this and this, okay, depends on positive and negative, and cosine having this and this, okay. This is positive, negative, positive, negative, okay. And how we are using which one is which, okay, which one is negative, which one is positive. Let me give you an example. Okay, R is 2 sine theta. This is, let me draw. This is 2, okay. And because sine in positive, then we get the circle on the top, okay. If we have R negative 5 sine theta. Now, remember, we don't have exact negative radius, right? But when you draw this negative, it's actually the same thing as you draw the positive one and you flip. Okay, that's the idea. Like we did on the graphing before. You get the radius positive, and when you have negative, it's behind the radius positive. Okay, so it's going to be like this. Okay, it's going to be having a circle. Okay, like that. Yeah, it's not in the middle, but let me just say that this is a circle, and this is 5. Okay, I think for sine and cos, like a cos theta or a sine theta, it's not too difficult. So the same thing with cos. If you have the positive cos, it should be here, and when you have the negative one, it should be here. Okay, it's not too complicated. Okay, let me remind you with the R Okay, we call this the limaçon. Sounds like you are French when you say limaçon. Limaçon. Okay. So A, B, sine or cosine. Okay. In limaçon, sine and cos will determine in which side the limaçon will be. Will having a large structure. Okay. Like for example, the sine is up here or down here. The cosine is left or right, and that's what will happen in the limaçon. Okay. Let me give you example. So for example, you have 3 plus 5 cos theta. Okay. Okay, now how to draw? Okay, because it's positive cos, it will having the right side. It having the big structure on the right side. Let me draw. Okay. Now for limaçon, you need to see this AB. We have several types of limaçon. Okay, but let me start with the first structure. A over B or 3 over 5 is less than 1, right? So the first one, A over B, is less than 1. It's 3 over 5, right? It's less than 1. So the limaçon will be limaçon with inner loop. So it will be having loops inside, okay? So we will have at least, okay, 1, 2, 3, 4. At least you have 1, 2, 3, 4 points. At least you will have 4 points, okay? This point, the far right point here, is 3 plus 5. It's 8, right? This 8. The point in the middle is the 5 and minus 3. The gap between 5 and 3 is 2, okay? And this point will be A, 3 and negative 3, okay? 3 is 3, okay? Now, yeah, more or less you will have like a heart, but with some inner loop inside. Okay, maybe one example is not enough. Let me give you another example. R is 2 minus 5 sine theta. Okay. First thing to note is A over B is 2 over 5, which is less than 1. Okay. So it will be limaçon with inner loop, which is the same as previous example. Okay. But the difference is we have sine and we have negative here. Okay. Okay, we know that the sign when it's negative, it's going to be down here. Okay. So 2, 5, we will have 7, 3, 2, 2. Okay. 7, 3, 2, and 2. So it should be, yeah, it should be like this. You can compare with the uh, graphing devices, what it should be looks like. But hopefully, with these illustrations, okay, with this illustration, at least if you have this kind of structures in your polar equations, you can tell how the graphs looks like, or is the limousine having inner loops or not, okay, based on the A, B, okay. It's helpful for this one, okay, if you know the inner loop. Now, the other example, if you have R 3 plus 3 cos theta. Now, the A and B, okay, A and B are the same. So when A, B the same, then it's not the inner loop, but the cardio, okay, cardio. But in cardio, it's actually, it works similar way with the inner loop, the limason. You have 6, 3 plus 3 is 6. You have 0, which means there's no loop. It's 0, okay? So you have uh, 6 maybe here, 6, okay? And maybe this is 3, this is 3. And you have like that, and it's perfectly like a heart, right? The cardiode. Actually, it should be a little like a circle, if I'm not mistaken. You can check what's the original cardiode looks like, okay? But as illustrations, you can just make it the key points, okay? 6, 3, 3, and 0 here. Now, if you have 2 minus 2 sine theta, it's minus, so it should be bigger at the downside. So you have, okay, you have this is 4, this is 2, this is 2. Should be, yeah, it should be like heart. Yeah. And what happens if you have this? A over B is greater than 1, right? So this should be the next structure. Okay. It's a limousin. Uh, the idea is actually, if you see the cardioid here, okay, and here, okay, if you see the inner loop, it's having inner loop, right? When you're having AB less than 1, and when your AB is equal, it's getting closer to 0 here. Okay. When AB is greater than 1, this 0 here is going up, right? So it's um, like like a dimple, okay? And when you're having greater than 2, it's become like a circle, but it's not a circle. I'll say that. Yes, the terms is convex limousin, which means it's way more dimple than before. Okay. So let's draw the so maybe around here is 9. This maybe 5, maybe 5. So let me write AB is greater than 1, or it's 5 over 4 greater than 1. Okay. We will have dimple limousin. So you will have, it's going, it's want to go to 0, but it's not. Okay. So it's a dimple like that. Okay. Then this is the dimple limousin. And the way it works, like the sine, the cosine, it's going to be the same. Sine will be going down or up, depends on negative or positive. For cosine, right or left. Okay, positive, negative. It's going to be the same way as the A cosine theta or A sine theta. Okay. Okay. Now one more examples for the limousin. Um, let's go for R 5 minus 2 cosine theta. So A over B is 5 over 2, which is greater than 2, right? Or greater or equal. So at least you need to have A over B equal to be to have the convex limousin structure. So it should be going to be the left side because it's negative cos, and it should be having 7 and Oh wait, one more thing. I forgot to mention. Should be 1. So it should be crossing 1. Just so this should be the A minus B here. Sorry, I forgot to mention. So A plus B, A minus B is A. Okay? So the A minus B becomes the other side of the this largest structure. Okay. Okay. Now here we have 7. We have maybe 5 here and 5 here, and this is maybe 3 around here. So it's like a circle, like an ellipse, but it's not. Okay. Yeah, that's the convex limaçon. Okay, so we have this kind of structure. Okay. This is limaçon with inner loop. A over B is less than 1. We have the cardioid. This is A over B is equal 1. We have the dimple. This is F greater than 1. And we have a convex limaçon. So we can say that this is the dimple limaçon limit is before it reaching 2. Okay, before it's reaching 2. So A over B uh, should be 2, or let me write. This is 1. Uh, let me just write A over B should be 2. Yeah. Okay, that's the limaçon review and example. Okay, any questions? Any questions? If I give you the polar equations, okay, I hope you can convert the polar roughly into the drawing. Okay, it doesn't need to be really like smooth or good. At least these 4 points you need to mention. Okay. Okay. Yeah, this is yesterday. Okay. Okay, now we are going to go to rose curves or petals. The terms will be r a sine and theta, and r is a cos and theta. Sine or cosine, similarly with before, it's acting as the starting point, which determines top, down, left, right. Okay, and now you have some multiplicity in the angle. Okay, it can be 1, 2, 3, 4, etc. Okay, so for let me write um, for even petals to n, for odd petals it's n. This is the number of the petals. Okay, if you have even petals, for example, you have 2, the number of the petals will be 2n. This is a number of petals. So if n is 2, then number of petals will be 4. If number of n is 3, then the petals is 3. Okay, that's the characteristic for the petals. Okay, so this is the summary, short summary from what we have graph beforehand. So they already make some classifications for even and odd based on multiplicity of the angles. Now, remember that if we have R, let me write in the next page, okay? But just make sure you notice the difference between the even and odd, okay? Even you need to multiply by 2. For odd, it's still the same as the n, okay? Okay, consider R is 2 sine theta. Okay, consider R is 2 sine theta. It is having the circle, right? The circle like that. Okay, having this, and this is 2. Now consider R is equal to sine. Now we have 3 theta. Now it's the n is 3. Okay, let me write the n. Okay. The n is 3. So the petals should be 3. Okay. And because it's 3, then we have the full circle is 2 pi, right? Or 360. Then the difference in angle between the petals will be 120 degrees. So each petals will have difference in 120 degrees. Okay, now let me draw the graph for you and let me explain later. So the graph will be like this. If you want, you can make a small circle. Okay, to help you draw, because we have only two, then 1, 2, 2 units. Okay, 2 circles. Then, okay, um, I will start drawing from this side. And then I should have the difference. Let me write this 270, 0, 9. Okay, so this 270, should be 150, and this should be 30 degrees. Okay. Okay, so why I know that the petals like this? Okay, so there's a pattern. There's a pattern. Okay. You see the n equal 1 is having at the top, right? So let me write for you. If you have n equal 1, you will have n equal 3. You will have, and you can add the 2. And when you have n equal 5, you will have at the top, and you add another 4 at the top, bottom, and going here. Okay. If you have 7, it will go from the bottom and the other 6. And how you divide between the petals, you can just use the difference between the degree. Okay. You have 120, and this n is 3, which means we start from the bottom, which means this is the 270. So from 270, we can go here. 120 becomes 150 here, and 150 goes here, become 30. Okay, it's a little bit weird, but yeah, the patterns works all the time. What happens if you have r negative 2 sine 3 theta? So you have r 2 sine 3 theta, right? What happens if you have negative 2 sine 3 theta? Hmm? Yes, correct. So you flip, so it's become this and this. Okay, so you flip this, flip the graph. So okay, now let me give you another example. R is 3 sine 5 theta. So the n is 5. So the petals should be the same. Okay. And the degree, the difference between the petals will be 72. Okay. And based on what I told before, if you start with the uh, n equal 5, then you start the petals from here and make the 4 petals. Okay. So start the first petals here. So because it's 3, let me make 3 circle. Okay. So the first petals is around this. And let me mention the degree. This 180, this 270. Okay, now because the difference is 72, so 90 going here is 162, maybe around here. And this will be around 2 to 3, 4. Okay. And this should be 306, maybe around here. And this should be 18 degree. So each petals 72 degree apart. Now if you have r equal to cos 3 theta, okay, remember you have sine 3 theta is like this, right? The sine is like this. So if you have cosine, you will have and all the same characteristic. So 0, this is 120, 240. Okay. Let me move to the even petals. Okay. If you have R 3 sine 2 theta, so n is 2, the petals should be 4, and the angle in between is 90. So for the even, uh, the patterns, my suggestion is having memorize one pattern, and then it can be replicated easily. For example, if you have 1, 2, 3. Okay. Okay. Now the patterns will be like this. And each will be having differences 90 degrees. And because it's symmetrical, right? If you have r negative 3 sine 2 theta, it will have the same, it will have the same graph. Okay? If you have the negative, okay? This is negative, this is positive 3. If you have the negative 1, because it's symmetrical, you flip and it will be the same thing, right? It will be the same curves. Okay. Okay, now if I'm multiplying the n with, let's say, 4 theta, these petals will become like 2. This 2, this 2, this 2 become 8. Okay. So the easy way to remember the graph looks the pattern. Okay. Let me draw the R. Let me write this is the same graph as R. No, 3 sine 4 theta. Okay. Yeah, it's not really good circle, but yeah. Okay. Now I'm writing the n equal 4. So the petal should be 8, and the angle difference should be 45. Okay. So remember the first pattern we have, the first petal is 45, right? Now it's twice. So let's divide by 2, become 22.5. Okay. So let me draw the 45 here. This is 45. Let me make divide by 2. So it will be here. Let's say this is 22. Okay. And this is our first petals here. Okay. Based on our pattern from the beginning. Okay. So this is the first pattern. And going up a little bit, plus 45. Okay. Plus 45, it's the around 67.5. So it will be like that. And plus again, it will be 1125. So basically you have this pattern. Okay. And that's the graph for the polar 3 sine 4 theta. Okay. We can, to make sense what we are doing, we can actually try to, let's say, add theta equal 67.5. Okay. Let's say our r becomes 3 sine 4 multiply with the 67.5. This is 270. Okay. What is the sine 270? -1, right? -1, right? So it should be -3. And what will happen in this graph? Okay. So it's going the mirroring. Okay. The same thing as we did before. And exactly at other degree, they will cover each other and they will make up this even structures. Okay. Same thing happen. You can check when 22.5 is 90, it's positive, right? So it's the correct one. It's similar to what the calculations is. Okay, but for 67.5, when you put in, you get 270. It's -3. It's not this one, but the other side. Okay, so it's kind of weird. The graph it's 77.5. The polar. His polar is the other side. Okay, and this one came from the other side. Okay, it's kind of weird, but yeah, in polar it's all true. Okay, so this is the even. Let me go back to this this sine 5 theta, and let me make another the odd one. Let's say 3 cosine 5 theta. Okay. Okay. To make sense, cos or and sine. Okay. Let's see here. Okay. If this is our sine, if we have the same sine 5 theta, we just need to. Can you see that? We just flip to the right side. Okay. So it will be. I will draw really quick here. It will be start from here, and then we can start make some other petals. Yeah, it's It's not symmetric. It's not really good, but yeah. I hope you can see that this is from this same graph, but you are flipping to the right side. Okay. And when you have the negative, it's from this. Yeah, from here, it's the negative, flip to the left side. Okay, okay, I hope you don't get mixed with uh, uh, cos and sine. But just remember, okay, uh, the difference between cos and sine in the petals, okay, actually it's kind of the same. Okay, the cosine, you will see the petals. If it is odd, one petals should be at least at this axis. Okay, for example, this one, this cosine. Okay, for sine, it will be this side, okay, or this side. Depends. Okay. If this is positive, then this side. Okay. And for cosine, this side. Okay. Let me um, move on to another uh, another. This is the even petals for sine. Let me move to cos, because cos uh, we already did the drawing before. Let me repeat that. 3 cos 2 theta. Okay, let me start with the 2 theta. So as we draw, we get this, right? Yeah. And of course, is n is 2, the petals is 4. The difference between the petals will be 90, which is true. This is 0, 90, right? This is perfectly uh, aligned with the axis of the degree, right? This is 0, 90, 180, 270, okay? Nothing wrong with that. What will happen if we multiply the angle? So now 2 becomes 4. Okay. In sine, you need to split the angle between become 2, right? From 45 become 22.5. Now here, uh, let me write the n. Okay, n is 4, p is 8. Okay, but which 8? So the idea for cosine, you will have the 4 same angle as the first one, but you add another one in the middle. Okay. So you have this and this. And let me give you the angle. It's 45. So from here, going 45 degree, this is another angle, 45. Okay. Okay. Uh, this is, so this is 90, 180. This is 45. I think that's the important thing in sine, cos, odd, even in Rose curves. Okay. I think the easy one is the even petals. The pattern's easy to draw. For odd, you need to um, look at, is it sine, is it cos, to determine in which directions the first petals is. Okay. If you know the first direction, it's easy to draw the other petals. Okay. And then determine the angles and make sure it's separate as, for example, 45 or maybe 22.5. Okay. Okay, that's the rose curves. So let me give you some time to breathe and to think. Yeah, it's a lot, but maybe I will give you some exercise. But I think the best exercise is having a graphing device with you and try to put in some equations and look at the design. So first you have the equations. You try draw by yourself and compare with the graphing devices. You can go to, I think you can go to the some free website and just drawing using that website. If you have the calculator that have capability to draw this kind of structure, then you can do it as well and try to make sure you find the right picture for the graphs. Okay, because now you're already um, in college, right? In university. The difference between college and high school, I think one of them being um, you can manage your own time, right? What I mean is in entire college life, you can choose which course you want to take, which is required, which one is elective, right? And you can choose whatever you want actually, as long as it is suitable or fit with the policy, right? Right. So I think if I really guide you from zero one by one, it, I'm it's like I'm not respecting you as a college student. I'm if I was if I treated you like that, then I treated you like high school, right? So my suggestion is you need to improve. Okay, you need to improve by yourself. Do not depend on the professors because the professors sometimes they cannot help you. Okay, um, you need to depend most of the time by your own ability. Okay, most of the time. Okay, because the skills you acquired is always with you all the time, right? And you cannot also depend on others. Maybe you will have some teamwork or maybe some group discussion, etc. If you depend also with your teammates, then it will also will not help you in the future. So you need to help yourself. Okay, it's not it's different from how to say that self become selfish. It's different. Okay, it's totally different. What I mean is you need to have your own skills. Okay, instead of maybe relying to others, depends on others. Okay, actually I read your homework. uh, I'm not sure you realize or not, but do you think you are doing by yourself or no? No, whatever the result is, the score is, I will always can see who's doing it by herself or who's look to other homework because I also was student, so I know the tricks. Okay, like 1 or 2 years ago, I'm having a student. Um, he was obviously cheating in exam. I know, but I don't want to disturb him. So okay, let it be. And then I see the results. Okay, and I just interview the students. Okay, can you come? Can you show your results? How you do the step by step for each questions? And then I remember I giving the same questions, but I changed the number. So so he want to do the same answer, but then then he cannot do it at all. Okay. So I told him, okay, if you want to cheat with me, uh, I know most of the tricks of the students. Sometimes they're using their phones, looking at they save the file to PDF and they are looking at the phones, and sometimes they look in the websites. Sometimes they go to the bathroom and it's taking so long, and it's obviously cheating. But I'm not like okay, you're cheating, blah blah blah. I'm just giving him, okay, I need to lower your score, but whatever the result is, you need to accept it. And then he say, okay, and then don't ever try with other professors. If they know you, you will be expelled, or the professor will give you an E without even any considering any score he has. Okay, so that's the, I think last year student. I think he should be graduated, but some course he failed, so he need to retake the course, and he did that. Okay, but I think at the end he still failed. I still calculated the score, and he still failed. So whatever you're doing, um, do by your own. Okay? Do not rely to others, especially when you're having evaluation on your ability or skills. Okay, um, that is my suggestion. And if you're having difficult times, that's totally fine. Okay, college life is always tough at several points, and different people will have different situations. Okay, I will not like okay, all the students, I will give this is okay. You need to be adjust yourself to your environment and to your friends, to your professors. um, yeah, I think that's my suggestions. Okay, we still have something left, but I think I'll just continue next week. There is just uh, one left for the structures, and 2 or 3 key points for the whole sections. Okay, so yeah, the quiz will be next 2 weeks. Okay, next 2 weeks, because I believe you will having a tough week, right? You have midterm, right? Chemistry, right? Okay. Yeah, so next 2 weeks our quiz, and every time you are doing homework in any course, I hope you're doing by yourself. Okay, it's to help you improve. Okay, to help you to improve. It's not always about the results you write, the score you get. It's about your ability to improve. Okay. Okay. I think that's all for today. Let's see you next week.